Welcome back, students. So in this video we will discuss about resistors in series. So I told you we can connect resistors in two different ways. One is series connection and the other one is parallel connection. Series connection means we will connect it back to back. Okay, we will connect it back to back. That is a series connection. So, resistors in series. So, this is a symbol to draw resistor. Okay, it is represented by R. Suppose if we want to connect three resistors in series means we will connect it back to back. So, first one, second one, third one. So, this connection is a series connection. So, three resistors, we will name it as R1, R2 and R3 are connected in series. Okay. So, this type of connection is known as series connection. Now, we need to derive the equation to find the effective resistance when three resistors are connected in series. Okay. So, the circuit diagram is given like this. We will connect three resistors back to back and from this end we will connect an ammeter. We will connect an ammeter from then to a switch here, then battery, positive, negative, positive, negative, positive, negative. Then we will connect it to the other end of the next to this end to the negative terminal of the battery. Now we need to connect a voltmeter across the three resistors like this. Yeah, voltmeter is always connected in parallel. Across the resistor or across the device, we want to measure the potential difference. Voltmeter is connected in parallel and ammeter is connected in series. Ammeter is connected in series. So, now we need to derive the expression for the effective resistance when three resistors are connected in series. When three resistors are connected in series. Suppose you consider the voltage given is V. V is the potential difference across the ends of the battery and this potential difference V will be divided among the resistors R1, R2 and R3, that is V1, V2 and V3. When you add the potential difference across these three resistors V1, V2, V3, you will get the potential difference across the battery. Okay. So, V equal to V1 plus V2 plus V3. V equal to V1 plus V2 plus V3. Now, consider I be the current flowing through the circuit. I is the current flowing through the circuit. Since only one path is there for the current to flow, means like this, when you connect three resistors in series to a battery like this having a volt V, R1, R2, R3 and I current will flow through this circuit. Let I current flows through the circuit. So, here only one path is there for the current to flow. Okay. In series circuit, only one path is there for the current flow, or we will say in another word, means same current will flow through the three resistors. Same current will flow through R1, R2 and R3. Okay. Now we need to find the potential difference across V1, means the potential difference across the resistor R1. What is the potential difference across the resistor R1? That is represented by V1. So, by Ohm's law, we know that V equal to I into R. So, here in series circuit, the current flowing through the circuit is same, means same current will flow through R1, R2 and R3, and that is I. So, I into R1. Okay, potential across this R1 resistor is V1, that is equal to I into R1. In the same way, we can find the potential across the resistor R2, that we will represent it by as V2, that is equal to I into R2. I into R2. Now we need to find the potential across R3, that is represented by V3, that is equal to I into R3. So name it as equation 2. Equation 2. Now this equation, name it as equation 1. So in equation 1, V equal to V1 plus V2 plus V3, and in equation 2, with the help of Ohm's law, we calculated V1, V2 and V3. Now we will substitute all these values in equation 1, that is V equal to, instead of V1, we will write I into R1 plus, instead of V2, I into R2 plus V3, we will write it as I into R3. Now just tell me, anything is common on the right hand side? Anything is common? Yeah, I is common. So we can take it out. So I into R1 plus R2 plus R3. I equal to V equal to I into R1 plus R2 plus R3. Now we will consider, name it as equation 3. Consider equation 3. Now you consider, here 3 resistors are there. 3 resistors are connected in series. Now instead of these 3, I am considering only one resistance. Instead of these 3, I am considering only one resistance, and that resistance will have a value equal to the sum of these 3 resistors. Okay. So, I am replacing these 3 resistors with a single one. The value of that single resistance and these 3 will be same. Okay. So, instead of this 3, I will use a single one having a resistance Rs. I current is flowing through that. V is the potential drop across the ends of that resistor. Now, by Ohm's law, what is V here? From Ohm's law, what is V? V equal to I into R. That is I into, here R is Rs, means the value of Rs and the value of R1, R2, R3. When you take the effective of this one, that will be equal to Rs. Okay, when you take the effective of that R1, R2, R3, you will get Rs. Okay. So, instead of V, here instead of this V, we will write it like this: I into Rs equal to I into R1 plus R2 plus R3. R1 plus R2 plus R3. Now, anything is common in this equation on both sides? I is common. So, we can cancel this I, and what we will get? We will get it like this. Rs equal to R1 plus R2 plus R3. This is equation to find effective resistance when three resistors are connected in series. Okay, when three resistors are connected in series, this is the equation to find the total resistance. Rs equal to R1 plus R2 plus R3 means we need to add it together. Okay, we need to add the resistors together. So, we will get the effective resistance. Now, we will do problems related to this topic, that is this one. The question is this one. Find the effective resistance and the total current in the following circuits. We need to find the total resistance and the current, total current, okay, in the circuits. Now, tell me how many resistors are connected here? 1, 2, 3, 4, 5 resistors are there. In which way they are connected? They are connected back to back, means in series. Okay, in series. Now, what is the equation to find the effective resistance when resistors are connected in series? Rs equal to, Rs equal to R1 plus Rs equal to R1 plus R2 plus R3. Here 5 resistors are there. So, plus R4 plus R5. Okay, R1 plus R2 plus R3 plus R4 plus R5. So, what is the answer? Rs equal to 20 ohm plus 20 ohm plus 20 ohm plus 20 ohm plus 10 ohm. What is the answer? 20 plus 20, 40, 60, 80 plus 10, 90 ohm. That is the answer. Effective resistance will be 90 ohm. Now, we need to find the total current. What is the equation to find current as per Ohm's law? I is equal to V by R. I is equal to V by R. V is 9 volt. So, 9 volt divided by 90 ohm. 9 volt divided by 90 ohm. That is 1 by 10 ampere. 1 by 10 ampere. That is the answer. Now, next question, this one. Here also 1, 2, 3, 4, 5 resistors are connected in series. How we will find the effective resistance? We will add the resistance. Okay. So, Rs equal to R1 plus R2 plus R3 plus R4 plus R5. That is equal to 4 ohm plus 4 ohm plus 2 ohm plus 3 ohm plus 2 ohm. Now, what is the answer? 4 plus 4, 8 plus 2, 10, 13, 15 ohm. 15 ohm is the resistance value. So, we need to find the current. I is equal to V by R. What is the potential difference here? 15 volt divided by 15 ohm, that is equal to 1 ampere. Okay, that is equal to 1 ampere. So, if you are asked to find the effective resistance when resistors are connected in series, we will use the equation Rs equal to R1 plus R2 plus R3 if 3 resistors are there. If only 2 resistors are there, then R1 plus R2. If more than 3 is there, then we will add it together. Okay. Next question is this one. Find a current through 12 ohm resistor. Find a current through 12 ohm resistor. A circuit diagram is given here. Here 4 resistors are connected in series. Okay. Only one path is there for the current to flow. Only one path is there for the current to flow. So, it is a series connection. So, 4 resistors are connected in series. How we will find the total current? We know the equation. I is equal to V by R. Here R S. Okay. V by R S. Because only one path is there for the current to flow. So, the same current will flow through this 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm. Same current will flow through all the 4 resistors. So, if you want to find the current, then I is equal to V by R S. So, what is for first we will calculate Rs. Rs we need to calculate. What is the equation? R1 plus R2 plus R3 plus R4 that is equal to 0.2 ohm plus 0.3 ohm plus 0.4 ohm plus 0.5 ohm plus 12 ohm. So, when you add it together 9, 12, 13, 14, 12 plus 1.4, 13.4 ohm you will get the answer. 13.4 ohm. 13.4 ohm, that is the answer. Now, we need to find the current, that is I is equal to V by R, that is V how much? 9 volt. So, 9 volt divided by 13.4 ohm. When you do the calculation, you will get the answer. Okay, 9 volt divided by 13.4 ohm. That is the answer. Okay, when you do the calculation, you will find the answer in decimals. Okay, now suppose n resistors are there connected in series. N resistors are connected in series having a value capital R. Each one is having a value capital R. N resistors are there. N resistors are there. They are connected in series and each resistor is having a value capital R. So, how we will find the individual effective resistance? R is equal to R1 plus R2 plus R3 plus etc. Rn. Okay. But each one is having a value R. So, R plus R plus R plus R. Okay. So, each one is having a value R. So, how will you find it? 1 plus 1, 2 plus 1, 3 etc. up to plus n. So, the answer will be R is equal to n into R. N into R. This is the equation. Okay. If n resistors are connected in series and each one is having a value capital R, then the effective resistance can be calculated using the equation R is equal to N into R. So, we will do some problems related to this one. Suppose 1, 2, 3, 4, 5. 5 resistors are there. 2 ohm. Each is having a value 2 ohm. It is having a value 2 ohm. So, R is equal to, we can use it R1 plus R2 plus R3 plus R4 plus R5, that is 2 ohm plus 2 ohm plus 2 ohm plus 2 ohm plus 2 ohm. So, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So, what is 4, 6, 8, 10 ohm, you will get the answer. 10 ohm is the answer. Okay. Here we can use the equation R is equal to N into R. So, N is 5. Here 5 resistors are there. Now, what is the value of R here? R is 2. R is equal to 2 ohm. So, we can find the effective resistance using this equation. R is equal to N into R, that is 5 into 2 ohm. 5 into 2 ohm, that is equal to 10 ohm. That is equal to 10 ohm. So, if n number of resistors are connected in series and each the resistance having same value, then we will, it's any shortcut method is there to find the effective resistance, that is R is equal to N into R. R is equal to N into R. Okay, thank you.